Knock, knock. You're supposed to say who's there. Let's try that again. Knock, knock. Who's there? Me, duh. Just kidding, it's John Cena. Da, 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 da. Okay. Hi, friends. Welcome to Class 9 of Unit 4, where we are going to continue talking about finding equations of lines, Part 2. Last time we saw, as long as we had the y-intercept and some way to find slope, finding the equation of our line is easy enough to do. As nice as it is, though, in the grand scheme of things, it's pretty unlikely we'll be told exactly where our line crosses the y-axis. Even so, as long as we have a point and a way to find slope, we should still be able to find our equation. So with a goal in mind, and the knowledge that it should be totally within the realm of our possibility to achieve it, the question of the day, our question du jour, what can we do if we aren't given the y-intercept? So for example, a line with a slope of 3 passes through the point 2, -5. We want to find its equation in slope-intercept form. So, give yourself a little bit of space. We're going to come back and answer this question. It turns out that there is a not-so-new friend of ours that is actually a repurposed version of another, even older friend, that will allow us to answer this question pretty easily. We've talked in classes past about the idea that different forms of lines serve different purposes really well. There is a particular form of a line that happens to be really good at finding equations of lines, and it's called point-slope form. Just like slope-intercept form gives us a slope and a y-intercept, point-slope form, as long as I've got a point, we'll call it x1, y1, and a slope of m, all I need to do is slot those into place in my point-slope form, and I should be good. It turns out that as long as I've got a point and a slope, I can write the equation of my line as follows. Point-slope form is y, general y here, minus that specific y1 from our point, is equal to m, our slope, times the quantity, or in other words, just a fancy way to say parentheses, of x minus x1. This form of a line is really powerful, and as such, I'm going to ask you to commit it to memory. I've done a rare thing of giving you something before showing you where it comes from. There's space off the side for me to show you that. But first of all, let's just show that it works. So y minus y1 equals m times parentheses x minus x1. Let's show that we can use this above to find our equation. So I know here, reading through, that I've got a slope and a point. So my slope here is 3. So I'm going to call 3 m. My point is 2, -5. So to stick with my labels, I'm going to call 2, -5 my x1 and my y1. I know that my goal is to use point-slope form to get to slope-intercept form. And the thing about point-slope form is that I think of it like an intermediary. There are some mathematicians who say you can leave any line in point-slope form. For me, it's a means to an end. It's a way for me to get to something like slope-intercept or standard form. Here I'm specifically asking you for slope-intercept. So I want to use this guy, y minus y1 equals m times parentheses x minus x1 to get to slope-intercept. Well, all I need to do, I've already found m, so I'm going to substitute the value of m for 3. I've got x, general x, right? I don't know what x is, but I do know x1. I've labeled that as 2. And then I've got y minus y1. I found that guy as -5. My goal is to get to slope-intercept. Give yourself a 1-minute timer, pause the video. Let's rewrite this equation in slope-intercept form, right? Y equals mx plus b. Go! Okie dokie. So, if I want to get y by itself, let's start by doing some simplifying. Well, negative, I can rewrite that as +5. And then 3, there are no parentheses in the slope-intercept form, so I'm going to distribute my 3 to each of my terms to get 3x minus 6 there. All I've got to do to get y by itself is move that pesky little +5 over to the right side. Subtracting 5 from both sides, I see that y is equal to 3x minus 11. That is allegedly the equation of our line in slope-intercept form. For those of you who don't believe me, and my encouragement is always to be skeptical, let's say I wanted to show that this is in fact the line with this point. Well, it's in slope-intercept form, so the thing attached to the x is the slope. Yeah, its slope is 3. To show that 2 comma negative 5 does in fact live on this line, what could I do? How could I check my work to show that 2 comma negative 5 is a solution? Very nice, invisible person. All I've got to do is substitute. So the y value of negative 5 is going to take the place of the y in my equation, equal to 3 times the x value of 2, and then I have a minus 11 over on the side. Let's show for sure that these two sides are the same. Well, I've got negative 5 equal to 3 times 2, which is 6, minus 11. Negative 5 is equal to 6 minus 11. 6 minus 11 is negative 5. Would you look at that? Point-slope form got us to a valid form of our line. Very nice. So there's point-slope. We know what it looks like, and we know that it works. Real quick, let me show you where it comes from. I've alluded to this idea that it comes from something we've already used, an old friend. What old friend does it kind of look like? Look back in your notes. Do you see anything here that looks sort of familiar to something we've done in this unit already? Go, 30 seconds. Alrighty. Remember when we were first working with slope? We said that slope is rise over run, but if we wanted to calculate it algebraically, if we took the difference of the y-coordinates of our 2 points, any 2 points, call them y2 and y1, and divide it by x2 minus x1, right, the difference of our x-coordinates, that is an algebraic way to find our slope. Notice how similar this kind of looks to point-slope form. It's got an x1, a y1. The only difference is that it has a general y and a general x, rather than the specific x2 and y2. So I'm going to really quickly derive, or in other words, show you where it comes from. Point-slope form. Well, my first move is going to be to rectify that mistake. The y2 and the x2, these are specific x's and y's, but it could be any xy, right? I have a general y here, a general x here. So my first move, I'm just going to swap out specific x2 and y2 for general x and y. So this is going to become y minus y1 over x minus x1. All I need to do now is make it so that m is multiplying by that x minus x1. Well, one way that I can do that is by multiplying both sides by my denominator. So on the right side, doing that removes our denominator. We're just left with the numerator of y minus y1. And then on the left, I have m times x minus x1. I'm going to choose to write it like that. And would you look at this? If I take this equation and flip the sides, notice that that gets me to the point-slope form that we just used above. Fantastic. So for the curious among you, you now know where a point-slope form comes from. And if you weren't curious, you still know anyway, and you're better for it. Cool. Let's get a little bit more practice using our point-slope form. The idea, as we saw last time, is that there are 5 cases where we might be interested in finding equations of lines. The first 3 we saw yesterday, or last time that you watched video 4.8. If I knew slope and y-intercept, I could just plug in. If I knew the y-intercept and a point, I could use the slope formula to find slope and then substitute in. And then finally, if I had the graph, right, I could count the rise and the run, I could find the y-intercept, and then I could slot everything into place in my slope-intercept form. Case 4, like we just did above, if I tell you the slope and I give you any point on the line, point-slope form can get me to my equation. So let's take these two. Again, use your point-slope form to find the equation of the line in slope-intercept form. We're thinking of point-slope like a way to get us to y equals mx plus b. Go ahead. Alrighty, so I know that I want to use point-slope form. What is point-slope form? Say it with me. Well, it's y minus y1 equals m times parentheses x minus x1. Again, our goal is to commit this to memory. So I have a slope of 1/4. That's going to take the place of my m. My point negative 8 comma 3, I'm going to label my negative 8 as x1, my 3 as y1. Plotting everything into place, or slotting everything into place, y minus y1, which is 3, is equal to m, which is 1/4, times parentheses x minus x1, that's negative 8. Simplify before we solve here. So I can rewrite x minus negative 8 as x plus 8, right? A double negative becomes a positive. So now I can distribute my 1/4. So this would become y minus 3 equals 1/4 x plus 1/4 of 8 is 2. All I've got to do now is add my 3 to both sides. When I do that, we find that y is equal to 1/4 x plus 5. There you go. There's your first one. And for the second, slope is negative 1/3. Again, this is going to be our m value. My point 3 comma 2, I'm going to label this as my x1 comma y1. All I've got to do now is substitute into our point slope form. Say it with me. It is y minus y1 equals m parentheses x minus x1. Plugging in, I know that y minus y1, we found that was 2, is equal to m, which is negative 1/3, times parentheses x minus 3. If I want to simplify, distribute our negative 1/3. Negative 1/3 times x, well, that's just negative 1/3 x. Negative 1/3 times negative 3, so negative times negative is positive, and 1/3 of 3 is 1. So I've got y minus 2 equals negative 1/3 x plus 1. All I've got to do to get y by itself is add 2 to both sides. That tells me that y is equal to negative 1/3 x plus 3. So there you go. There's case 4. Given a slope and any point on my line, it doesn't have to be the y-intercept. I can use point slope to find my equation. The last case where I might want to use point slope, maybe I give you something like this. I don't explicitly tell you what the slope is, but I tell you 2 points that live on the line. Could be an x-intercept and another point, could be a y-intercept and another point, could just be 2 random points. But I want to find the equation of my line. In order to use point slope form, right, think strategically. What do you need, and how can you take what you've got here to get there? Go. Give yourself 30 seconds. Game plan. All right. Well, in order to use point slope form, right, that's my goal. I need a point and a slope. I've got points galore, but if I want to find slope from 2 points, to find slope, I can use my slope formula. So my opening move, I want to start by finding slope. Often, right, I could get it in the form of a graph, but often it'll just be 2 points. That means I probably want to use my slope formula, y2 minus y1 over x2 minus x1 to calculate the slope. So my opening move, let's find our slope. So here, I know that 4 comma 4, maybe I'll choose to label this as my x1 and my y1. Maybe I'll make my negative 1, 0, my x2 and my y2. Again, it doesn't matter which one is which, but plotting everything into place, I know y2 minus y1. So here that would be 0 minus 4 over x2, which is negative 1, minus x1, which is 4. Taking this guy and simplifying, 0 minus 4 is equal to negative 4. Negative 1 minus 4 is equal to negative 5. Negative 4 over negative 5, a simpler way to write that would be 4 over 5. So my slope here is 4 over 5. Now, all I need to do is use my point slope form. Again, point slope form is y minus y1 equals m times parentheses x minus x1. So my second move, once I find slope, I've got 2 points. So I'm going to take one of them. It doesn't matter which one, and use that in my point slope form. So I'm going to use one of my 2 points in my point slope form. Cool. So from here, in this case, notice I've already labeled the 4 comma 4 as the x1 comma y1. If you wanted to use the -1, 0, you absolutely could. But in the interest of making my life making my life easier, thinking smarter, not harder. I always mess that up for some reason. I don't know why. I've been saying it for 4 years. All I need to do is slot things into place. So y minus y1. Notice here I've already identified a y1 up above of 4 equals m, which we've found is 4/5 times x minus our x1 of 4. All I need to do now is get y by itself. So let's simplify before we solve. Right, I'm going to need to start by getting rid of these parentheses. So y minus 4 is equal to 4/5 x minus, I have 4/5 times 4. Well, 4/5 times 4, as a quality of life choice, if I'm doing fraction multiplication, might be wise to do what here? 5 seconds, 4, 3, 2, 1. Let's rewrite 4 as 4/1. So I've got 4/5 times 4/1. Hopefully that makes it more obvious for me that what I've really got is 4/5 x minus 16/5. I have y minus 4 on the left. I want y by itself to get into slope-intercept form. All I've got to do is add 4 to both sides. So I have -16/5 plus 4. Well, I need to, if I'm adding something with a fraction, I need a common denominator. So let's take 4 and rewrite it as a fraction of 5. 5 seconds go. 4 is how many fifths? 4, 3, 2, 1. Well, if I'm rewriting 4 as a fraction of 5, 4 is equal to 20 divided by 5. So I'm going to add -16/5 plus 20/5 to add those fractions together. All I need to do is add their numerators. So I have 4/5 x. -16 plus 20 gives me 4. And then all of that is over 5. There you go. There's the equation of your line. One more for the road, and then we're free. Let's find the equation of the line through the points -5, 1 and 5, -4. Again, start by finding your slope, then use your point slope form, and then you're good. Have fun! Alrighty, no more fun. I'm John Cena, and I'm coming to get you. So, I'm going to start by finding my slope. Again, it doesn't matter which one is which. Maybe I'll call this one on the left my x1, y1. I'll call this one on the right my x2, y2. To find slope, again, I know that slope can be calculated by taking the difference of the y values and dividing it by the difference of the x values. Slotting everything into place. y2 is -4 minus y1 is 1 over x2, which is 5, minus x1, which is -5. Simplifying our fraction, -4 minus 1 is -5. 5 minus -5, that's really 5 plus 5, right? Double negative becomes a positive. -5 over 10, this guy reduces to -1/2. So my slope, my m value is -1/2, and I want to use point slope form all together now. Point slope form is y minus y1 equals m parentheses x minus x1. With this, all I've got to do is get y by itself. So y minus y1, as I've used above, is 1 equals m, which is -1/2, times parentheses x minus x1, which is -5. Simplifying here on the right side, I've got -1/2 times x plus 5, right, again, minus a negative becomes a positive. Let's distribute our -1/2. So that's going to give me y minus 1 equals -1/2 x. -1/2 times +5, well, that's just -5 halves, right? Half of 5 is 5 halves. And then all I need to do to get y by itself is add 1 to both sides. So I've got y is equal to -1/2 x. I have -5 halves plus 1. Again, I need a common denominator in order to combine these two. Well, 1 is 2 over 2. -5 halves plus 2 halves would give me -3 halves. There you go. There's the equation of your line.